Welcome back, ladies and gentlemen. Today we're going to be talking about a real-life example on how we can use scientific notation, or that's used actually every day depending on your profession. So let's get right to it. So here is the sun, and here is the earth. If you compare them in real life, I'm sure you've seen lots of videos. If not, you can find some fantastic videos on YouTube, and I'm sure there's new ones coming out all the time. Just to be able to try and give us an idea of scale of the universe, especially with this planet of ours we think is so huge, and then we can put it up against things like the sun, and the difference in size are just, oh, they're astonishing. So when we really grasp scientific notation, you can really just start using abbreviations and short ways to think of very large ideas, and it's amazing. So here we're going to talk about how many times greater is the diameter of the sun than the diameter of the earth. And it actually is nice that it's going to tell us the diameter of each one. We don't have to calculate it. We don't have to find out the radius and do all this to find the circumference and dividing by pi to find out the diameter. We don't have to do anything weird. It tells us exactly what the diameter of the earth and what the diameter of the sun is. Now, what we're going to do from this point forward is we've got to figure out how to compare. In other words, we're trying to figure out how many of the earth would create, or how many diameters of the earth are going to create the diameter of the sun. How many groups would it take? How many earths could we set side by side to reach the entire diameter of the sun is another way to think about it. So the best way to do it that I know, I mean, we could sit here and do a lot of things. We could convert these to standard form, then we could do the multiplication, the division, and everything else that we need to do. In our case, it would be division because we're breaking it into groups. How many earths would go on here? Well, here's one earth and blah, 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 blah. We can't just take the picture. It's not a good representation. But what we can do is we can rewrite this as 1, 2, 3, 4, 5, 6. So I have 6. And it is a large number, so I'm going to keep it as 10 to the 6th, and 1.4 times 10 to the 6th. So now we have scientific notation for both the sun, or the diameter of the sun, and the diameter of the earth. And if we look at it, it's 1.4, 1.28, seems pretty close, but we got to remember, I'm multiplying by 2 more 10s in the sun than I am in the earth, meaning this is 10 to the 4th, this is 10 to the 6th, that's a difference of 2 10s. So we really got to figure out what that means. So what we're going to do is we're going to figure out how many times can the earth fit into the sun along the diameter, when I lay the diameter of the earth on top of the diameter of the sun. To be able to get this figured out, all we got to do is figure out how many groups it goes into. So groups is division. So I'm going to, how many times can the sun be divided up by the earth to equal 1 full sun? And that is, I'm just copying down, sorry for the pause. There we go. So we got 1.4 times 10 to the 6th over 1.28 times 10 to the 4th. Once we've done this, we can take out our calculator because we do want to do the division here, because remember, that's the same as 1.4 over 1.28 times 10 to the 6 minus 4. I just kind of combined a step or two, but this is kind of the short way of thinking about it. So what I'm going to do is I'm going to take 1.4 and divide that by 1.28. And I'm going to get this long decimal. Now, because it's so long, I'm going to go ahead and shift over this way, but understand that all of this is vertical movement down. 9375 times 10 squared. Okay, so let's figure out what this means. What it means is, if I'm going to solve how many times greater is the diameter, I have to figure out how many diameters of the earth can fit into the diameters of the sun, and that's 1.09375 times 10 squared. Well, that 10 squared says 1, 2 movements to the right because that's positive, and I get 109.375 earths fit on the diameter of the sun. So this is now a true statement. 109.375 Earths fit on the diameter of the sun, which means, so the sun, let me capitalize, is 109.375 times greater. So sorry, I did forget a word. The diameter of the sun is 109.375 times greater than the diameter of Earth. And after my correction is added in there, we have our final answer. How many times greater is the diameter of the sun than the diameter of the Earth? It's 109.375 times greater. Or if we took the Earth and grabbed it where the diameter touches and moved it and put it on the diameter of the sun, we would have 109.375 Earths side by side by side by side by side in a straight line to be able to go from one side of the sun to the other through the middle. All right, make sure you go ahead and pause that video and copy what's on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write down what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but make those notes yours. Last, ladies and gentlemen, when you're learning, it's about understanding the process, not about finding an answer. We'll see you tomorrow.